Point in the lecture, we're going to turn to hypothesis testing, and here we're going to introduce a number of key concepts that'll be important for the rest of the course. So put on your thinking hats, unless you have them on already, and try to follow along. Okay, so when you have sample statistics, those are statistics that apply to just the characteristics of a sample. But what they're trying to do is estimate the population parameters. So anytime I have a sample mean, it's trying to estimate mu. So if I want to know how hard my first test is, I can give it to a sample of, say, 5 students and see what they get overall. And that gives me some idea of what mu is. But it's not going to be perfect because those 5 students aren't the entire population. I can only know mu perfectly if I gave the test to everybody. So just like the sample mean tries to estimate mu, R is trying to estimate its big brother rho. So this thing here, by the way, is not a P. It's the Greek capital R. So don't get that confused with P. It's not P. Okay, so to review here, if I have a sample coming out of a population of SAT scores, does it make sense that even though overall people might have an average of 500 on the SAT, in a given sample of, say, 10 people, sometimes the sample mean might work out to 530, sometimes it could be 450, sometimes it's going to be 470. Why do the sample means differ from the population mean? Because of, you should write this down, sampling error. Sampling error causes sample means to not exactly be perfect in their representation of mu. So in the same way, let's imagine that our rho, the correlation at the population level between two things, say, excuse me, SAT and GPA, is really 0.27. In other words, if I had data on everybody in the world, including you and your brother and your favorite schnauzer, that would mean the true correlation is 0.27. But if I just have a sample of 10 people, say I take 10 people from our stats class and I look at their SAT and GPA, it could be that R would work out to be 0.15, or R would only be 0.41, or R might be 0.36. There's going to be some variability in these sample statistics and trying to estimate this population parameter, which is rho. So again, why do these differ from this? Because of our old nemesis, sampling error. You should shudder slightly when I say that, sampling error. Okay, so one way to think about this is samples can lie. There can be false alarms. So it might be the case that rho is really equal to 0. In other words, there ain't no correlation between these two things I'm interested in, but R might lie to you. Yes, it might lie to you. So let's say I'm looking to see if there's some relationship between someone's music ability and their math ability. So I have correlations on that. Now, God tells me, because he likes me, he told me he's okay with you, but he likes me, that rho is equal to 0. In other words, there's really no correlation between music and math. They have nothing to do with each other. Is it conceivable, though, that we might get some R values like this, 0.15, negative 0.22, 0.32, 0.02, etc., just by chance? Because the sample's not that big. These are close to 0, but they're not perfectly 0. So the key point here is these are all false alarms. We look at these and we might think there's really a correlation between music and math, and there's not. So this is an example of what can happen when rho really is equal to 0, but you still get correlations that look like rho is equal to some other number. So here's the hypothesis testing logic that you need to get. There's 2 logical possibilities. One we call the null hypothesis. So you should write in here NUL, null. That's a 0 right there. Null, I'm saying null, NULL, is another name for 0. The null hypothesis claims that rho is equal to 0. That's saying, hey, you know what? There's really no relationship. There's nothing going on between these two variables. Say, for example, music and math, there's no relationship. If you're high in music, it doesn't mean anything about how you're going to do in math ability. The other logical possibility, called the alternative, so write that, alternative hypothesis, represented here with an A. The alternative hypothesis is that rho is not equal to 0. That's a simplistic, or a simple way of saying rho is either some positive value or rho is some negative value, but there's something going on. according to the alternative hypothesis. So stop for a second and think which one is saying it's just sampling error that's causing any difference I see between 0 and the observed R value. So stop for a second and start when you've answered that for yourself. All right, you should have said this. The null hypothesis is the one that's saying that there's no relationship, that it's just sampling error. Down here, we're claiming something's going on. There is some relationship. So we need to make a decision, and the decision is either to reject the null or retain the null. If I reject the null, that's a good thing. So I know for the men in the room, the idea of rejection being a good thing is a little painful, but in this case, rejecting a null is what you want to do. Retaining the null, we're not happy with, because that means we can't show that there's a relationship. We have to retain or keep the idea that the null might be true, that rho might really be equal to 0. So we always make our decision in terms of the null. We don't make it in terms of the alternative. So how do you know when you reject the null? Well, I'll tell you. You've already been doing this. You reject if the chance of a false alarm is less than 0.05, if it's less than 5%. So we use the p-value in the correlation matrix to make that decision. So if you're looking at a possible correlation between music and math ability, let's say it turns out like this, where R is equal to 0.021, P is equal to 0.928, and that there's 20 people. So you can see if it turns out this way, we have one p-value, and this way we have a different p-value. In one case, p is not less than or equal to 0.05. In the other case, it is. So in this case, p is greater than 0.05. It's too likely that rho is equal to 0. Because look here. See, the correlation here is only 0.021. That's pathetic, right? The 0.928 is telling you that there's a 92.8% chance of a false alarm. Oh my goodness, that's just way too high. So we have to say the correlation is not significant. The way we would summarize that is R with 18 degrees of freedom, that's 20 minus 2, is equal to this R value, and it's not significant, N period, S period. If it turned out like it did down here in the second box, we'd say, woohoo! P is less than or equal to 0.05. We'd call our mother, we'd call our brother, you'd pet your favorite pet schnauzer, and you'd say, we get to reject the null hypothesis. Typically, we want to reject the null hypothesis because that means the correlation is significant, that it's reliable, that we found a relationship between music ability and math ability, and we're happy. So summarizing it in this case would be R with 18 degrees of freedom is equal to blah, comma, P is less than or equal to 0.05. Okay, so let's practice this. With that p-value there, if I'm looking at verbal ability and quantitative ability and seeing if there's a correlation, what would you do with that p-value? Well, p, the cutoff is what? P needs to be less than or equal to 0.05. You can write that in. And rho is either not equal to or equal to 0. So in this case, what are we going to do? Are we going to conclude that there really is a correlation in the population, or are we going to be careful and say there's not? Is the observed correlation significant or not? Well, in this case, we'd say the correlation is significant, that we think there is a correlation at the population level because the p-value is below 0.05. Remember, p is the chance of making an error, so if it's smaller, that's good. We like that. That means we are more likely we can conclude that rho is equal to some number other than 0. So what's likely if we connect another sample? What's likely to happen? We're likely to, again, find that quantitative ability and verbal ability are correlated. So how would you summarize R here? So take a second and do that, and then start the video again when you're ready. So how would you summarize that? You would say R with 22 degrees of freedom, it's 24 minus 2, R with 22 degrees of freedom is equal to 0.468, comma, P is less than or equal to 0.05. That's R with 22 degrees of freedom in parentheses is equal to 0.468, comma, p is less than or equal to 0.05. And here I'm just reminding you, don't confuse the p-value, this number here, with rho. They're two entirely different things. Okay, and then you need to recognize that there are, inevitably, when you do this, decision-making errors. So let's say that we did our study here, and we had music ability and math ability, and we found out that there is an R value of 0.102. Based on the p-value, what would we conclude? We'd conclude that it's not significant. We'd say, pah! With an R value of 0.102, it's pretty unlikely that there really is a correlation with the population. So we're going to retain the null hypothesis and say that the correlation is not significant. But if you collect more data, the result could stay the same or change. So here, what happens? Now we get an R of 0.21. Our p-value is still really high. On the left side, if we increased our sample from 10 up to 20, we'd still stay with the initial decision. But it could be that it turns out like here on the right-hand side. We add 10 more people to our original 10, and the pattern changes. And suddenly, music and math ability do correlate, and our p-value is below 0.05. So in that case, we would reject the null hypothesis and say, hey, we found a significant difference. So either decision you make, if you decide to retain the null hypothesis like we did here, or if initially you reject the null hypothesis like we ultimately did here, if you collect more data, you could be shown that you're wrong. Those are two kinds of errors. Later we'll learn which one's a type 1 and which one's a type 2 error, but for the moment you just need to realize that you're still making a guess when you retain or reject the null hypothesis. It's an educated guess, but you can be wrong. Okay, so comprehension check. What you should know about correlation by this point. You should be able to summarize an R value in the proper format, read the SPSS matrix, etc., and I'll let you just read through the rest of those. But these are things that you definitely should be able to know how to do at this point. If you don't, you need to go back and watch the video some more, or write down what your specific question is and make sure you ask me. All right, hope you enjoyed. Thank you.